In this video, I'm going to show you how to obtain the U statistic in the Mann Whitney U test as demonstrated in the textbook. The data I use here is same as the example used by the authors in the book, and you can get the data from table 4.1 on page 72. First, I want you to pay attention to how the data is structured here. We have two independent groups, and they are students taught by two different methods. So method is the first variable entered here. Variable shows up as columns in our data set. Second variable is a score. That's the student score in the class taught by the two different methods. In addition to the two variables, I also add a column for student ID. Then, since we have a total of 14 students in the entire sample, so there's one line for each observation, student 1, 2, all the way to line 14. Be clear that in the independent samples test, we have one independent variable. Here, the method is the independent variable that has two values. The two values separate the entire sample into two groups. And we have the score, which is the dependent variable. Okay. To get the U statistic, first, we put all the scores together and rank them. If we have two groups, okay, all students in the two groups, their scores are put together, and then you do the ranking. To make the ranking easier in Excel for myself, I'm going to go to this sort and make sure I'm going to sort this data set by score from small to large as shown here. Then I gave ranks to the score. So it's pretty straightforward since we do not have any tied scores. So I'm going to do the ranking manually. After we rank the scores, we want to put students back to their original group. So I'm going to simply sort by student ID. Now they're back to group, that's method 1, another group for method 2. At this point, we want to find out the total of all ranks for students in the same group. So I have summation of rank in group 1 here that equals the sum of all the ranks in group 1. So I did equal sum, then highlight the 7 scores, and here the sum is 70. I'm going to do the same thing for all the students in method 2. So I find out the total of their ranks. Here we go. We have a total rank for 70 for group 1 for method 1. The total rank of 75 for student in method 2. Now we are ready to calculate the U statistic for the group, for group 1 and 2 separately. You can see the formula here, and I have U1 and U2, that's the U statistic for group 1, U statistic for group 2. In both formulas, you can see we need N1 and N2. What are those two values? This is actually the size of group 1, how many observations in group 1, how many observations in group 2. In our example, both of them happen to be 7. N1 equals 7, N2 equals 7. Okay, so I just need to do the formula step by step. So I'm going to do this equals 7 times 7, that's my size of the two groups, then plus Now we're going to have a division there. So I'm going to do this. I'm going to do a parenthesis and again n1 times n1 plus 1. That's the numerator. Then divide by 2. Then minus the total ranks in group 1. Okay, I got 7 for group 1. Group 2, repeat the same steps. I'm going to do n1 times n2 plus, in the parenthesis, the numerator n2 times n2 plus 1, then divide by 2, subtract the total ranks of group 2. So between U1 and U2, we select the smaller value. That's the U statistic we're looking for. So U equals 7 in this example. To make a decision whether to reject or to retain your null hypothesis, you need to go look up the critical value for the U statistic. So the critical value can be found in table B.4 that started on page 245 in the textbook. Since we have both group size, that's 7, and we have alpha equals 0.05 for a two-tailed test. So alpha divided by 2, we're going to use alpha equals 0.025. That gave us the number on page 246. N1, N2 was shown as N and M in the table. So if you use M equals 7 and N equals 7 in the table, for the section alpha equals 0.025, you get a U critical that is 8. So U critical value, that is 8. That is 8. Compare the two. Since this observed or obtained value is lower than the critical value, we are going to reject the null hypothesis.